Good evening, Professor Voiculescu. My name is Tingi Alessandro Lorigiano. I'm a student at Concordia in your class for electronics. And today, over the last couple days, I built a light-dependent LED oscillator circuit. So it uses an LDR, a photoresistor, in order to gauge the light intensity of the environment, and it produces an oscillation dependent on the amount of light present. I just want to start off the video by saying that I tried to, as you can see, I tried to emulate the dice problem where I use 3JK flip-flops in order to randomly generate a number for the dice, but there was a problem in the making of the circuit, and so I decided to pick something easier at the last minute. And so so to get on with the video, this circuit, its primary function is just to determine how much light is in a room and control and oscillate a DC voltage, turn a DC voltage into an AC voltage, which is an oscillation, and control an LED. There are very limited secondary functions, as I explained in the report, since there's only an LED attached, but as I explained, you can attach a different consumer to the circuit instead of an LED, and you can derive a lot of functions for the circuit. So, just to explain how the circuit works, I'm using an op-amp with a couple resistors for the negative feedback, and I have a capacitor that's attached to also the negative feedback, which creates an RC constant between the LDR and the capacitor. And then we also have the 9 volt voltage source over here powering it, which alternates the V plus input of the op amp between it alternates between 4.5, or that middle point is always at 4.5 since it's a voltage divider between two resistors. But so to take some measurements, yes. I wanted to take the measurements of the output of the op-amp and also the voltage across my current limiting resistors seen by my LED. And these values should show the oscillatory behavior of the circuit. And so in order to do that, I just need to lower the amount of light in the room by using the potentiometer on the wall. And now I'll be able to verify some values. So if we can just keep the multimeter in the reading as well, if we can see it. Is it too dark? No, I think we should be able to see it. So so there, we have the multimeter, and I will be looking first. First, let me connect the power. Oh, so just to see the circuit working. My apologies, I should have done this earlier. But so yeah, as we can see, when there's no light present, the LED is blinking, and as I increase the amount of light in the room, the LED stops blinking because the frequency is very high. So so it looks as if it's constantly giving an output voltage, when in reality it's actually should be alternating between 9 volts and 0 volts constantly. So just quickly, since I'm approaching this 4-minute mark, I just want to show the voltage across the LED alternates between 0 and about 4.5 volts, which is exactly what we expected, since the output voltage is 9 volts. The forward voltage of the LED is about 2.5 volts, meaning there should be the rest dispersed from after seeing the LED. So it goes from about 6 to 0 alternating. And then secondly, we're just going to attach this to the ground. I have a ground wire just here in order to easily determine. And when I look at the output voltage of the op-amp, it alternates between 3 volts and 6 volts. And the rest will be discussed in the report. Thank you very much. Sorry for going over time very slightly. Cheers. And that's